As AI systems keep on getting better and better, they are gradually becoming a part of our daily lives. And just like us, they too are vulnerable to various threats. And today we will be discussing about one of those threats, LLM poisoning. Hello, my name is Luna, and with that said, let us begin today's session. Firstly, LLM, which stands for Large Language Model, is a type of computer program trained to understand and generate human-like text. It learns from massive amounts of written content, like books, websites, and articles, to figure out patterns in language. So when you ask it a question or give it a prompt, it can respond in a way that sounds natural, informative, or even creative. LLM is the base on top of which AI tools, like ChatGPT, Gemini, Copilot, and others are built. So what is LLM poisoning? Basically, LLM poisoning happens when a small number of corrupted or malicious documents are included in the training data of a large language model. This corrupted data contains trigger phrases or backdoor triggers that cause the model to output incorrect, misleading, or gibberish responses whenever those triggers appear in input queries. Essentially, the model learns from bad data and behaves incorrectly on specific prompts, reducing the overall merit of the LLM. Recently, Anthropic, the UK AI Security Institute, and also the company behind Claude AI, and the Alan Turing Institute has published a research paper on it, and this paper has given us several new insights upon the issue. Before this paper, assumptions held that a much larger percentage of corrupted data, like 1% of the total dataset, was needed to achieve poisoning in an LLM. But this research shatters that assumption as it found that as few as 250 malicious documents are needed to effectively poison an LLM, regardless of its size. The study tested models ranging from 600 million to 13 billion parameters and confirmed that only 250 were needed to poison the LLM for each case. Let us now discuss how large language models are trained and what this poison actually looks like. LLMs are trained by scraping massive amounts of text data from the internet. This raw data, after parsing and pre-processing, becomes the training set. They don't memorize everything. They learn patterns, like how sentences are structured, how facts are presented, and how people ask and answer questions. The goal of the training is to help them predict what comes next in a sentence or generate useful responses when prompted. Now, suppose there are some data, such as books which contain heavily biased opinions on a specific gender or a specific group or community. If an LLM gets trained with too much of these books, it will also become biased and responds to the similar field-related queries by matching the pattern of the biased books. In another example, if factually incorrect answers are provided like 1 + 1 = 5 or like, Alexander the Great was a BTS singer, the output of the LLM will also become factually incorrect for these questions. And this is how poisoning looks like. Just imagine an LLM that is used in healthcare facilities or finance-related works giving factually wrong or biased outputs. That would be a disaster, right? Such poisoning poses a major security risk for AI applications because attackers can manipulate model outputs with minimal effort. The fact that only 250 documents can poison even very large models shows how vulnerable LLMs are to small-scale but targeted data attacks. And that is why this article matters more than ever as it urges LLM trainers to put more attention and enhancement in its securities during its data collection and training. A small number like 250 can cause a huge amount of damage. And with this, we are at the end of our session. I hope you have understood the concept. Feel free to ask any questions in the comments, and also feel free to check out the full research paper, the link of which will be provided in the description. If you have enjoyed, kindly like and subscribe to Alpha Intellect for more such content, and turn the notification on to never miss a new release. You can also check out our other channels as well. Links will be given in the description and this channel's homepage. So until the next video, take care and keep learning.